Well, a good day to you. Welcome to Back to Basics, and today we're talking about parallel and perpendicular lines. Before we really talk about what we do with them and what the numbers are behind parallel and perpendicular lines, let's talk about what parallel and perpendicular mean. Parallel lines never intersect, ever, except for an infinity, but that's a different discussion that you can talk about in college. Parallel lines will never intersect. So if you look over there, you have two lines that will just simply not touch each other. And if I were to slap that on a coordinate plane and try to go up and over and find out what the slopes are, it's obvious what the slopes are. They're the same, the exact same. Parallel lines have the same slope. It's just if one's a little bit higher than the other, it has different y-intercepts. That's it. Parallel lines have the same slope. And if you're talking about coordinate planes, they have different y-intercepts. Easy, but they will never intersect. Ever not in a million years. Maybe a billion, but not in a million years. Perpendicular lines, however, as you can see from the graph, they do intersect, but intersect in a very specific way. Look at that graph over there. If I were to look at that graph over there, I might be able to say, I could find out that one slope appears to be, let me see, the red slope appears to be up 1, 2, 3, 4, 5, 6 over 1, 2, 3. So this red slope appears to be 6 over 3, which is 2, or 2 over 1. And that blue line appears to be negative up 1, 2, 3 over 1, 2, 3, 4, 5, 6. Negative 3 over 6 is negative a half. Well, one was positive, one was negative, one was a half, and one was 2 over 1. Perpendicular lines are the same thing, but one's negative and flipped, also known as negative reciprocals. A reciprocal is when you take a number and reflip it. Oh, I'm sorry. Flip it. Oh, I accidentally made reciprocals sound like reflipricals. What an accident I made. Bing. I didn't make an accident. And I haven't in many years. Thank you. Lost my train of thought. Okay, so I have one is going to be positive and one's going to be negative, and the other one is going to be the flipped version of the other. So if I found out that a line was a half and I wanted to find out what the negative reciprocal of a half is, it would be negative 2 over 1, or just negative 2. If I gave you negative 3, I might think, well, negative 3 is the same thing as negative 3 over 1. So you flip that and take the negative of a negative, which is just a positive. So perpendicular lines, their slopes are negative reciprocals of each other. I don't care about their y-intercepts. I only care about their slopes, and their slopes are negative reciprocals of each other. And you find the negative reciprocal by flipping it and making it opposite. Flip it, opposite, flip it, opposite, flip it, opposite, flip it, opposite. Find if the two equations are parallel, perpendicular, or neither. Okay, I can do this. In a previous episode, I used standard form to find the slope, but what I'm going to do is to find the slope for this blue guy is I'm just going to solve for y like I normally would. So I'm going to solve for y like I normally would. I'm going to subtract 3x from both sides, minus 3x, cross u out, drop down the 4y. I'm going to write this out in a way that makes me happy because it'll look more like slope-intercept form. Minus 3x, positive 12. I'm going to divide everything by 4. I'm going to divide u by 4. I'm going to divide u by 4. And now I need to find the slope. Well, now that y is all by itself, the slope is negative 3 over 4 because when y is all by itself, the slope is the number in front of x. So my slope for the blue guy is negative 3 over 4. That is point slope form. When you're in point slope form, the number in front of the parentheses is my slope. So I'm just going to say, well, my slope is 3 over 4. So compare 3 over 4 and negative 3 over 4. One's positive, one's negative, which means it can't be parallel. Wait a minute. Wait. One's negative 3 over 4 and one's regular 3 over 4. So they're not flipped versions of each other, which means they're just neithers. They're neithers. Okay? So I did it. Neither. It was a close one, though. It's like I purposely did that. I did. Find an equation parallel to that guy right there and goes through 5, 6. Well, if I'm going to find something that's parallel, I care about them having the same slope. Well, look at this guy. That's point slope form, which means the number in front of x, or the number rather in front of the parentheses, is going to be the slope that I want. So the slope that I want is m. Hooray! It also goes through that. And that's a point. So I needed a slope, and I'm given a point. I'm going to use point slope form again. So I'm going to label my point x sub 1, y sub 1. So again, I'm given a point, and I need to find a slope, so I'm going to use point slope form. What's point slope form? Y minus y sub 1 equals m times the quantity x minus x sub 1. What's my y sub 1? 6. So y minus 6 equals m. What's my m? Negative 3 times the quantity x. So popular. Minus x sub 1, which is 5. No trickery. That's my answer. I'm done. So as you can see, they both have the same slope, but since they have different points, if I were to do the math out, they would have different y-intercepts. And if you're like, well, let's do the math. That looks terrible. No. Because in a previous episode of Back to Basics, I said that if I ask you to find an equation and you write it out in point slope form, well, by golly, that's perfectly fine. Sorry for cursing. I don't like cursing. But sometimes I just have to get my point across, and I don't know how else to do it. Oh, my point across. My point slope across. Now what I need to do is I need to find an equation perpendicular to that guy right there in standard form. But it also needs to go through negative 1, 4. I'm not given the slope right away. I'm not. So what I'm going to do is I'm going to take that guy and solve it for y. Why am I going to do that? Well, if I get y all by itself, then the number in front of x is my slope. So I'm going to add 2x to both sides. Add 2x to both sides. I did this in a previous problem. That gives me 5y equals 2x plus 1. And I wrote it out as 2x plus 1 to make it more look like slope-intercept form. Y is not all by itself. I'm going to divide everything by 5. I'm going to divide everything by 5. I'm going to divide everything by 5. Y equals 2/5 x plus, who cares? Because my y-intercept doesn't matter. All I care about is my slope. What is my slope? 2/5. However, the slope that I want has to be perpendicular to that. And perpendicular is the negative reciprocal of 2/5. What's the negative of a positive? A negative. And if I flip the 2/5, I get 5/2. So there's my slope. Oh, look, a point. So I will label that point. So if I have a slope and I have a point, guess what I have? Point slope form. So I have y minus y sub 1 equals m times the quantity x minus x sub 1. My y sub 1 is 4. Y minus 4 equals my m, which is negative 5 over 2. X minus x sub 1, which is negative 1. That double negative looks terrible. Yeah, that'll do. And that's it. That's it. Point slope form is A-okay with me. I'm running out of space according to my computer, so I'm going to end this video now. Bye!